sometimes it pays to be the tortoise. Slow and steady wins the race. And I've gotten farther faster because I was methodical then and actually understood stuff rather than just doing the minimum that I needed to get a job done. Okay, I've also read the official book on Git. It's called Pro Git. The link is there. You could read this too. It's free online. This is the book that the Git website itself recommends. I've spent maybe between 20 and 40 hours reading that book. And it was so helpful. Now I feel like I really have mastery over what Git is doing. And hopefully in the end, you will be glad that I did so that I could pass on that mastery to you as much as I could. All right, my AirPod just told me it's dying, so try to do that. Okay. So if you're struggling with Git for the assignments, hint, this might be a place to go. Now notice that manuals and reference documentation are two different things. I would say don't try to memorize details that you can look up later. So if you see like API reference documentation and that kind of stuff, there might actually be some helpful overview like material. Like for example, actually, I hadn't thought to show this example, but JavaDoc for file. This is something that I used extensively in both the tests and my solution for the assignment. This Java IO file class. This is basically a manual for this class, right? It's talking about what is this concept. This is probably worth reading. This is a good foundational concept for the assignments that you will want to read. That said, this is all reference information. Probably don't need to read this. This is stuff that, understand maybe what's there, but don't try to memorize the facts about this. It's available to look at whenever you need it. Don't try to memorize facts. That's not what I'm talking about when I'm talking about digesting things in your mind. I'm not talking about facts that you can look up. I'm talking about understanding, seeing how things relate, seeing what the concepts are, seeing, how concepts relate to things. All right, but yeah, so manuals and reference documentation are different. Don't try to memorize details that you can look up, but do pursue understanding of how the system works. Okay, story time. And after that, we'll have an exercise. Okay, this is another story from the debugging book that I will read to you. Actually, sorry, any questions before I read this? Questions so far? Going once, going twice. Okay. A junior engineer, we'll call him Junior, working for a large computer manufacturer, was designing a system that included a chip called a 1489A. This chip receives signals from a communication wire, like the kind between a computer and a telephone internet modem. One of the senior engineers, we'll call him Knee Jerk, saw the design and said, "Oh, you shouldn't use a 1489A. You should use the old 1489. Junior asked why, and Knee Jerk replied, "Because the 1489A gets really hot." Well, being suspicious of all older people, as brash young folk tend to be, Junior decided to try to understand the circuit and figure out why the new version of the chip got hot. He found that the only difference between the two chips was the value of an internal bias resistor, which made the new part more immune to noise on the wire. Now, this resistor was smaller in the 1489A, so if you applied lots of voltage to it, it would get hotter. But the resistor was connected in such a way that it couldn't get much voltage, certainly not enough to get hot. Thus, understanding the circuit, Junior ignored Knee Jerk's advice and used the part. It did not get hot. A few months later, Junior was looking at a circuit that had been designed by the group previously. As he put his scope probe down on what the diagram said was the input pin of the old 1489 they had used, the pin number didn't seem right. He looked it up in his well-worn data book, and sure enough, they'd gotten the pin out wrong and connected the input to a bias pin instead of the input pin. The bias pin is generally supposed to be unconnected, but if you hook up the input to it, it sort of works, though the part has no noise immunity at all. This misconnection also happens to bypass an input resistor and make the part draw a lot of current through the internal bias resistor. In fact, Junior noted with amusement, it gets hot. And it would get hotter if you used a 1489A. All right, so there's a lot of technical terms in there. Hopefully you got the point of the story. And the point was that Junior took the time to understand what this component, this chip was, how to use it, what the different pins are. And he understood that, whereas the rest of the team didn't. And the rest of the team, he found out, had connected it wrong. And that's why they were having problems with the new chip. Okay, I also have a story to tell about debugging. This is one that I wanted to share. Okay, I haven't actually thought about how to share this. Basically, I was in college and I had developed something of a reputation amongst my peers that I had installed Linux and compiled kernels, and I was hacking around in Linux and setting up servers and things like that. And I actually used this for a job that I did on campus. And so I was kind of one of the go-to guys for doing this kind of stuff. Go-to people. And at one point, I think it was either the summer before my senior year or the summer after my senior year. I was doing an internship at the time, and one of my classmates who had a successful business he approached me to help him with some system administration stuff that he didn't know how to fix. And so I did some moonlighting work in the evening hours to try to fix his system. I think I charged $50 an hour or something like that. And I spent like 40 hours trying to figure this stuff out. And I failed. I failed miserably. I was trying to set up this mail server, and I didn't know what I was doing. And I did not take the time to slow down and read stuff. I was just trying to read the internet. This was before Stack Overflow or Server Fault existed. I was trying to find quick fixes as much as I could. I'd try that, it wouldn't work. I'd try something else, it wouldn't work. It would behave a little bit differently, which made me think of something else. So I tried to fix that, and that, it was just a mess. I was thrashing. And I just utterly failed to do anything useful for this guy. And he actually reached out to somebody else who was a little bit more senior than me and said, hey, can you help Jeff? Can you help him figure out what's going on? And this guy came in and he was very methodical. And he said, well, have you tried this? What is this doing? What did that do? What does that mean? And just walked me through it in a very methodical way. And as soon as they did that, I was like, okay, I see how you're approaching this. It's very different than how I was. And you're actually the one making progress on this problem. Okay. So I was very embarrassed that I did a bad job and I failed at that. But it was a good learning exercise for me. It gave me a good story to pass on to you. And I want to also convey too, like, part of the point of me telling you this story is that I'm in this kind of like exalted position as a professor in front of the room telling you about how to do all these things. I'm the sagacious one who knows everything. So it might seem, but that's not the case. I wrestle with this stuff. There's plenty of things I don't understand. Even in doing some of these assignments, I occasionally have bugs where I have to stop and think like, okay, what's actually going on here? I actually have understood Git already, so I'm a leg up in that regard. but I'm not understanding here. I need to take a step back and approach it differently. And I still fail at this. So I want to give you permission to fail because I think that's just a part of life as a software engineer. Okay. We've got about 5 minutes left. There's a reflection exercise that I will activate in just a second. After that, I have some foundational concepts. I've kind of made a menu of different things that you might think about how well you understand. And if you understand all of these foundational concepts, probably you will understand assignment 3 better. So I'll get that. I'll show that slide in the end. And if people have time and want to stick around, I can probably discuss some of these underlying concepts if that would be helpful. But before we get there, I'm going to open up this reflection exercise. That again is wholeev.com/Jeff Terrell, since you had questions on that if you can't see the URL. Okay, so I'm going to start a 5-minute timer on this. Okay, that's our 5 minutes. We're actually at the end of class. I realized I forgot to record that whole thing, which is really frustrating to me. I think I'm gonna have to go back and give that whole thing all over again so that people who couldn't join us today can watch it. But anyway, if anybody is able to stick around, I'm not sharing. When did I stop sharing my screen? Gosh, I hope I was sharing my screen that whole time. Anyway, feel free to leave if you need to run or if you're not interested in reviewing some of the foundational concepts. But if you want to stick around and discuss some of these foundational concepts for assignment 3, feel free to do so. I think for starters, let's just have use the chat room in Zoom to say if anything in this list or anything not in this list would be helpful to talk about. So Kevin says hexadecimal and Unicode. I could definitely do that. Any other votes for that or for anything else? Format of blobs, trees, and commits. Definitely could talk about that. Yep. Any other votes for those things or for anything else? Okay. Okay, let me start with I think this will be fairly quick. The blobs, trees, and commits. There's a couple things I want to talk about here. Let me think about where to go for this. Git SCM. So here's that pro Git book. Git objects. Right, this might be one of the best resources that I could share with you for. Oh, I'm not. No, I was sharing video. Whoops. Just not. Okay, there we go. This might be one of the best resources I could share with you about this topic. This might be worth a good read and work through, but let me find. Yeah, there's some diagrams here. I'm trying to find. Okay, so this object storage section might also be useful because this is talking about the header. This is what you've seen in the assignments as well, but you know, object type, content length, a null byte, and then the actual content of the object, whether that's a blob, commit, or tree. So anyway, I would just point you at this resource and say that might be worth a read if you're still not sure you understand some of those concepts. Any follow-up questions about that? Feel free to unmute and talk if you like, Rachel, or anybody else. Okay, great. And Kevin asked about hexadecimal and Unicode content. Let's see here. I'm thinking Wikipedia is probably a good resource for this. So if it makes sense to say this is base 16 numbers, and that might not make sense. If it doesn't, that's fine. But the basic idea is like, normally with numbers, we have a base 10 system. So our digits are 0 through 9. Hex is, and then like you got the ones place, the tens place, the hundreds place. and then that's a base 10 system. With a base 16 system, you've got digits from 0 to 15, and hexadecimal notation says that A is 10, B is 11, C is 12, up to F is 15. So those are your digits. And then you have the ones place, the 16th place, the 256th place, and so on up from there. So that's the idea in terms of a number system of hexadecimal. And yeah, here's a good table. So each hexadecimal digit from 0 through F captures 4 bits of information, a bit being 0 or 1. And a bit is a base 2 numbering system. So you've got only 2 digits, and you've got your 0 place, your 2 place, your 4 place, your 8 place, and so on. But a hexadecimal digit captures 4 bits of information. And so 0 corresponds to the bit pattern 0000. 9, for example, is the bit pattern 1001, and so on. So this might be a good place to read if you're not sure about hexadecimal, but the key thing to notice is that there's a very direct correspondence between a hexadecimal digit and a certain number of bits. And in fact, if you have 2 hexadecimal digits, that's 1 byte, i.e. 8 bits of information. So when you're dealing with binary data, hexadecimal notation is a really useful thing to use, because then it's easier for us as humans to kind of read it and see what the information is. So you can transfer between hexadecimal string or hexadecimal number, if you will, and binary data. And that's a transformation that you can make with no loss of information whatsoever. Any other questions about hexadecimal? Okay, can you explain the intended input-output types for get bytes, byte array, SHA-1 bytes, SHA bytes, and 2 hex string? Understand the relationships between these things. Yes, can do. And before I do that, let me briefly mention Unicode. I've pointed a number of you at this article from 2003, The Absolute Minimum Every Software Developer Absolutely Positively Must Know About Unicode and Character Sets, No Excuses. This is still a good read to understand just the basics of what Unicode is. But the key thing to notice, I wonder if there's something I can quickly point you at. Right, up until now, we've assumed that letter maps to some bits in which you can store on disk or in memory. So in the past, a character was exactly 1 byte, no exceptions. But with Unicode, you might need to have multiple bytes. So let me see here. Yeah, there's a difference. Okay, so this gets into some details, but basically the takeaway here is that you have a string of 5 characters. Well, those 5 characters might not be 5 bytes. They might be 7 bytes, or they might be 9, or they might be 5, or they might be 10. And it depends on what the encoding of the characters are. And that's where Unicode comes in. And so if you're trying to interpret binary data as a string in Java and in Clojure and in most modern languages, it's going to be assuming that binary data is Unicode data. And so even though you're reading in 20 bytes of an address as binary data, if you're trying to interpret that as a string, it might be an 11-character string, even though it's 20 bytes. And so if you try to concatenate that with some other string that has 9 characters, then you're going to get a string that has 20 characters in it rather than one that has 29, which is what you should get. And so it just makes things all weird. So that's kind of the reason why we have to be careful about strings versus bytes, is because of Unicode, and we can't just interpret bytes as strings, otherwise we run into trouble. So let's talk about some of these functions that I provided. So 2-hex string is going to take some number of bytes as a byte array, and it's going to convert that into a hexadecimal number, a base 16 number, and it has to be represented in Clojure as a string because it's not like a, it has letters in it, right? It's got like A through F in it, so you need to use a string to show it. I think there is a way. I think you can say OX in Clojure to get an actual hexadecimal number. That would be something you could do, but I don't know how to display that that way. But anyway, so 2-hex string takes a byte array and gives you that hex string from it. And if you understand hexadecimal notation, you'll understand that you get 2 characters per byte. The opposite function is from hex string. So that would be if you had a hex string and you wanted to get the actual byte array out of it. That would be the function call, and that would be the mirror images. You get the exact same information in both senses, both the hex string and the bytes, but it's just a different representation of that same information. If you want to go from a string to bytes, a string to a byte array, then you can say .get bytes. You call the get bytes method on the string. So if I go to the Java doc for string, Clojure strings are java.lang.string objects, by the way. I have this method here, get bytes. Look at that, it returns a byte array. So I can call the get bytes method on my string objects and get the bytes out. If I wanted to, I could then send those bytes to hex string to get that into a hex string so I could see what those bytes are in a way that's a little bit easier for me to understand. And if I'm concatenating things together, which happens like when you're dealing with tree objects, well, it happens in a lot of places, but one of the trickier places is with tree objects, because if you take a single tree entry, here, for example, you've got, well, let's look at the header, or that's the header. Let's look at the entry. We've got the mode, we've got the file name, we've got the null byte to separate the file name from the address, and then you've got the address. And we need to stick all this stuff together to get the entry. And in this particular case, we already have the header in that string as well. But we need to combine string data with binary data. And this is where we run into problems if we're not careful. So if we just said concat this string to this blob address without calling get bytes on the string, then we would be converting the blob address to a string and then converting or concatenating that as a string to the string. And that's where we would run into problems, because our binary data interpreted as a string would be some different number of bytes. You asked, are the bytes returned from .getBytes encoded in Unicode? Yes, you get to see the raw encoding of Unicode if you say get bytes. I think, actually, that's an interesting question. I thought I knew the answer to that, but now I'm doubting myself. Yes, into a sequence of bytes using the platform's default character set, storing that result into a new byte array. The behavior of this method when this string cannot be encoded in the default char set is unspecified. The char set encoder class should be used when more controlling over the encoding process is required. So I'm not sure I completely understand that. I would need to go and understand and digest kind of what this class is, and I would probably want to go back and review this article on Unicode, but I believe the answer to your question is yes. Get bytes is returning the actual Unicode encoded byte of the string. Okay, so then To concatenate, we want to concatenate not as strings, we want to concatenate as bytes, because we want this blob address, which is in binary, to be concatenated as a byte array so that we get all of the original bytes without having Unicode mess with our bytes. Yeah, and there's still something odd about how that works. I think what's happening there is like Unicode is messing with our bytes because well, I don't know. I don't know that I understand that well enough to fully explain what's going on, but the problem is that, again, multiple characters, multiple bytes might be considered a single character. So the length of your string might be different than the length of your binary array. But okay, so this actually does work. So we call concat. Concat just takes a sequence. And so the byte array here is converted to a sequence, a closure sequence. The byte array here is also, the byte array returned by get bytes is also cast as a sequence. Concat returns a sequence. And then we use byte array to get back to the actual byte array. I don't know that we actually need to do that. I'd have to play around with it to know for sure, but this gives us a byte array again. This blob address is binary because we did our SHA-bytes function this way. So this is calling the digest method on the SHA-digest instance. You could look up the Java docs for all of this to understand what's going on there. But this is kind of the recipe that we have for getting the SHA-bytes. And the thing to know about it is that it returns a byte array. So our blob address is a byte array. It is binary data. It's 20 bytes long. If we convert it to a hex string, that's 40 characters long. Again, there are 2 hex digits per byte. And this is a way for this to be kind of human readable, so that if you are running this on a REPL, you can easily compare to see if it's the thing that it should be. But then that binary data is what we're concatenating here. So this concatenation, I think, is the source of a lot of confusion in the assignment. So hopefully I've explained that a little bit better now. The thing to do with multiple entries is that you would concatenate those on the end of this. And usually what I would suggest is to have the header be some other method, some other function that you do that takes the object type and the object data. And then it just gives you a header with the object type, the data length, and then the data itself. So I wouldn't actually recommend writing your final code this way, but this is a way to show how addressing really works. I think I covered everything you asked about. Does that, and Ben also mentioned Montag has some slides from 411 that would be helpful for understanding hexadecimal and some of the stuff in more detail. But any further questions about that or about any other of these underlying concepts? Okay, if nobody has any other questions, then I guess we're done.